Let's solve Unit 7 Data Structures and Algorithms questions. Lower triangular sparse matrix is one. First, we need to understand about sparse matrix. What is a sparse matrix? Matrix having most of their elements as 0 will be called as sparse matrices. I'll give you a matrix representation now. This is a diagonal sparse matrix. If the diagonal part is alone having elements other than 0 and the rest of the elements are filled with zeros, this is diagonal sparse matrix. So you can see only the diagonal elements as 1. The rest of the places the elements are 0. When more number of 0 entries are present, those matrices are sparse matrices. If there are non-zero entries below the diagonal, then that is called lower triangular sparse matrix because the lower part is alone. This part is actually similar to this structure. So whenever non-zero elements, that is elements other than zeros, are present in the lower triangular part, it is called as lower triangular sparse matrix. We are not worried about the zeros that are present in the upper side. We are always concerned about the non-zero elements that are in the lower triangular part. What about the case where lower triangular part becomes the space for more 0 entries while the upper part is having elements greater than 0? That case will be called as upper triangular sparse matrix. Now the question is about lower triangular sparse matrix. We shall see which option is actually matching this matrix structure. Lower triangular sparse matrix is one in which all the non-zero elements lie only on the leading diagonal. Option 1 is actually talking about diagonal sparse matrix where non-zero elements are lying only on the leading diagonal. The second option, all the non-zero elements lie above leading diagonal. It is talking about upper triangular sparse matrix where all the elements are lying above leading diagonal. Elements in the sense non-zero elements. The third option, all the non-zero elements lie below the leading diagonal. If this is going to be the diagonal, all the non-zero elements lie below them. This is actually perfectly matching to lower triangular sparse matrix. Option number 3 will be the right answer. What is the fourth option? This is not defined for sparse matrix. It is not the case. Lower triangular sparse matrix and upper triangular sparse matrix along with diagonal sparse matrix are defined. So there is nothing called no definition. This is also ruled out now. So these two are present in the diagram. For this question I am just ruling out the options. Next question. Match list 1 with list 2. F of n is equal to a into f of n by b plus g of n. This is a divide and conquer recurrence relation for the algorithms in list 1. Match their recurrence in list 2. Before starting with these algorithms, we will just see what are all the algorithms that will apply the divide and conquer strategy. DNC applications are listed as binary search, merge sort, quick sort, median finding, minimum and maximum finding, matrix multiplication and closest pair problem. Now let's see the algorithms listed in list 1. Let's start with binary search. In binary search we are actually dividing the elements into 2 and we are only searching in one half of the element list. Here we can equate it to, we divide the problem into 2 sub-problems with each of size n by 2. If you take the problem as n, that is n number of elements, the binary search is concerned about searching only n by 2. So in that case we can take this as size n by 2 and solve one t of n by 2 sub-problem. The complexity is t of n by 2 with respect to one sub-problem. What will the t of n equation be? It will be t of n divided by 2 plus big O of 1. This will be the complexity case. And here this is equated to option number 4. This n by 2 is what they have mentioned in f of n by 2 and big O of 1 is just a constant, so here constant 2 is placed. Binary search is mapping to list 2 fourth option. A4 is found in option number 4. So let's check the other options too. Finding maximum and minimum of a sequence. While finding maximum of a sequence, you have to travel the similar way, t of n by 2. While finding the minimum of a sequence, you have to go the same way we can take it as 2 into t of n by 2. In that case, we can equate it to 2 of the options here. 2 into f of n by 2 and 2 into f of n by 2. So even while searching for a particular maximum or a minimum number, you will end up with big O of one complexity only. This is going to again equate to a constant, namely 2. This makes clear that B is mapping to option 3 in list 2. Just substitute this value here. You can find the value of A to be 2. And G of n, it will be a constant 2. When G of n is having a complexity other than big O of 1, there you can apply other variables. But since it is big O of 1, we can equate it to 2. It's a constant. Now the third algorithm, merge sort. What happens in merge sort? If the number of elements are greater than 1, then divide them into 2 equal subsets. This is actually n by 2 part. The algorithm is recursively invoked on the subsets. So if I take a list of elements here, I am just dividing it by 2. This subset is also divided by 2. Again, this subset is divided by 2. It keeps on recursively dividing it, and the returned sorted subsets. So at the last place, you will have a minimal subset that will be sorted. So these two will be sorted and we will get this part. Then these two will be sorted and we will get this part. Again, this way if we go, we will get a sorted part here, and this will be merged together to give the complete sorted list. This is what they have said. Returned sorted subsets are merged to provide a sorted list of the original set. So here also you are making 2 into n by 2. Because one way you are recursively dividing, the other way you are merging it with the sorted list. So 2 into n by 2 is here. Now let's see the t of n equation. 2 into t of n by 2, it is mapping correctly, plus big O of n, because you are working with n number of elements for the sorted list. In that case, this big O of n is what is mentioned as n here, if n greater than 1. In that case, merge sort will be mapping to option number 2. C2. Fast matrix multiplication. We will just see about matrix multiplication. In order to compute the original n cross n matrix multiplication, we have to compute 8 matrix products. So we are dividing the n cross n as 8 into n by 2 matrix, and when you compute 8 into n by 2 matrix, you will have 4 into n, right? So 8 matrix products along with 4 matrix sums will be there. The matrix product part is divide strategy, and followed by 4 matrix sum, which is the conquer strategy. This is what the representation will be when we take n by 2 cross n by 2 matrix. That is what is mentioned here. Out of these 8 matrix multiplication, since they have mentioned it as product, one product, that is one multiplication, is redundant. It means it is repeated, and this is found by the person called Strassen. That's why when explaining this algorithm, they will mention as Strassen's matrix multiplication. But here it is about fast matrix multiplication. But this is just to tell you that this was 8 into n by 2. Since one of the matrix multiplication is redundant, we are just converting this as 7 into n by 2. This is a justification to say why 8 into n by 2 is 7 into n by 2. And this part is just for the multiplication. For addition, it will be n cross n matrix, means you will have n square as the value. Let's see the t of n part. 7 into t of n by 2, which is equating here correctly, and big O of n square is for addition, because multiplication followed by 4 matrix sums they have told. So this is addition, and this is equated to n square here. This is not exactly the equation. Actually, these are the recurrence relation, and this complexity is taken from Master's theorem. So I am trying to map the Master's theorem complexity along with this recurrence relation so that you can compare it and understand it. By the way, where is this recurrence relation explained? It is actually explained in discrete mathematics books. That's why I wanted to map it with Master's theorem. We can map fast matrix multiplication to option 1 in list 2, D1. Option number 4 will be the right answer. Next question. Arrange the following prefix expressions based on their values in increasing order. There are two ways to evaluate this prefix expression. One way is using stack and the other way is using normal evaluation. This is non-stack evaluation, I can say. Whether it is stack or non-stack, you have to start from right side and move towards left. All the expressions will be evaluated this way. In stack method, what we will do is, whenever there is an operand, you have to push it into the stack. And whenever you find operator, you have to pop two operands out of the stack and then do the operation using the operator present here. Say for example, if the stack is going to have 3 and 2 and the operator is going to be plus, you have to take out 2, 3 and place the plus operator like this and then compute the value as 5. This is how you have to keep doing until you find a value for the expression. Now the work here is actually 4 times because you have to evaluate all the 4 expressions, find the value and then the answers must be arranged in increasing order. I will solve A and B using stack, C and D without stack. I will present you both the methods, whichever is comfortable for you and whichever is time efficient for you, you can use that. Let's take the space for A, B, C and D. So whatever answer we get, we will fill it here and then we can arrange it in increasing order. Let's take the A expression. Now we have to take a stack. In stack, I said we have to go in this order. So there are 4 operands in the starting, 2, 3, 4, 8. So we will push all the 4 operands together. Since we have pushed everything into the stack, we will just cancel them for our clarity. Now what is the operation available? Division. When I have an operator, I have to pick 2 operands from the stack. So what are the top 2 elements? 8 and 4. So I am taking 8, I am taking 4 and placing the operator in between. So the top element is 8. So I am picking it now. I am placing the operator. Then the next element is 4. Once I pop out 8, the next top will be 4. So that 4 is also taken. What is 8 divided by 4? It is 2. Now instead of 8 and 4, I have to place 2 here. This will be the next stack. So what is the top element here? It is 2. Division is over. After division, what do we have? We have an operand. Operand means what we have to do? We have to push it into the stack. I am pushing 2 here. So I will cancel 2. Now we have to do multiplication operation. This 2 is taken out. I am going to multiply along with this 2. 2 into 2 will give 4. So we are placing 4 in the top of stack. These 2 operands will stay as it is. After multiplication, we have subtraction. What is 4 minus 3? These 2 operands. This is equal to 1. So the stack will have 1 as the top element now. What is the next operation? Plus. What is 1 plus 2? This is equal to 3. So the final answer will be 3. A has the value 3. Let's go to the expression B. We have 3 operands together. So we are placing it in the stack. This will be like 5, then 5, 2, then 5, 2, 4. This is the way you have to bring it to this part. We have an operator here. It is multiplication. What is 4 into 2? It is equal to 8. So we are placing 8 here. Next to the multiplication operator we have 3. So we are inserting 3 here. Next we have another 3. We are pushing it here. So both the 3's are pushed into the stack. After 3 we have multiplication. So this should be 3 into 3. What is 3 into 3? It is 9. 9 will be placed here. 8 and 5 will stay as it is. This is also done. Next is minus operation. 9 minus 8 is equal to 1. Now 9 and 8 will go and 1 will stay here. What is this arrow mark given here? This is exponentiation operator, that is power. If I say it is 1 power 5, you have to multiply 1 for 5 times. This symbol is actually used in discrete mathematics book. What is 1 power 5? 1 power 5 is 1. We will have the answer 1. Now let's take the C expression. So hereafter we will not use stack. I will just try to evaluate using this expression itself. So whenever you go for non-stack, you have to search for the first operator, that is from right to left order. Here you have operand, operand and operator. When you find an operator, you have to pick 2 operands that are present right of the operator. If there is a plus here and you have 2 and 3 here, you have to make this as 2 plus 3. Now we will apply the same thing. We have to put this minus here. So consider these 3. This will be 4 minus 2, which is equal to 2. Now this part is evaluated to 2. Now again we have an operator. We have to pick 2 operands. So the operands are 6 and 2 along with the operator. This will be 6 divided by 2. Always place this operator in between the operands. Addition and multiplication are fine. For subtraction and division, 2 by 6 and 6 by 2 will totally change the story. So go with 6 divided by 2, which is equal to 3. This will be 3. Next we have to go for the power operator. This exponent operator is having 2 operands next to it. This 3 need not be disturbed as of now. We will just consider only these 3, because the operator and the 2 operands are alone taken for the operation. Even though there are 3 operands, we are not worried. We have to consider only these 2 operands. What is 2 power 3? 2 power 3 is multiplying 2 for 3 times, which is equal to 8. Now we will place 8 here. This 3 is untouched. That's why I am writing the 3 as it is. We have another exponent operation here, the power operation. This time it is 3 power 2. It means we have to multiply 3 for 2 times, which gives 9. And this will be 9 here. Now we have the operator minus. For subtraction, we have to pick these 2 operands. 9 minus 8, which is equal to 1. So we will place 1 here. Now it is 1 plus 3, which is equal to 4. This will have the value 4. C is having the value 4 as the answer. Now the final expression D. We will evaluate it in the similar way as C. We have to go for the first operator. It is plus. Pick only the next 2 operands. Don't worry about 3 as of now. What is 1 plus 1? This is equal to 2. Place 2 here. Go for the next operator. It is power operator. This will be 3 power 2, which is equal to 3 into 3, which is equal to 9. So I have to place 9 here. Now we have 1 operator and 2 operands. Altogether this will be 3 plus and this 9. This will be equal to 12. So we will place 12 here. Then we have plus operator again. This will be 3 plus 12, which is equal to 15. We will place 15 here. Now we have only 1 operator remaining. It is 15 into 3, which is equal to 45. So the final answer for D will be 45. Place 45 here. We have to arrange the values in increasing order. These are the values. We have to go in ascending order. That is smallest to largest. Which is small here? B. Then we have A. Then we have C. Then we have D. 1, 3, 4, 45. This will be the order. It is perfectly matching in option number 2. Option 2 will be the right answer. Next question. A least integer n such that f of x is big O of x power n for each of the following functions. Arrange according to the value of en in increasing order. Where is the n? It is in the power of x. So based on the complexity degree, you have to arrange them. I wanted to explain in an elaborate way. I will complete that explanation, and after that I will tell you for examination point of view how you should solve this in a quick time. So let's start with the elaborate way. F of x is g of x. It means f of x. What does this symbol mean? It means the value alone is less than or equal to c into g of x for all x greater than k, where c and k are constants. This is the statement. We are going to just rearrange this statement here. There is a pair c and k such that f of x is less than or equal to c into g of x whenever x is greater than k. This question is going to be for big O of x power n. In case the question turns for what is the pair c and k, you have to know this elaborate method. So let's start solving the first f of x value. Let's take f of x is equal to 3 into x cube plus log x the whole power 4. We know that log x grows so much more slowly than x. that every power of log x grows more slowly than x. What they are trying to tell you is log x is less than x. 3 into x cube or log x, which is higher power here. While taking only the power here, 4 might be higher. But when we say log x is less than x, you cannot say that log x power 4 is greater. So in this case, 3x cube will be greater. This term dominates. It means you have to consider 3x cube for finding big O of n. When there is an equation like x square plus 1, how will you find the complexity? The complexity is based on the degree. So we will say this is big O of n square. Similarly, when they say there is x square plus x, higher degree will be considered for complexity. Compared to x power 3 and log x power 4, x power 3 is going to dominate, means the complexity is going to depend on x power 3, the degree 3. So here we can say big O of x power 3. This is going to be the complexity for f of x. F of x is big O of x cube because we know log x is less than x. We have to present this in this form. So let's take 3x cube plus log x power 4 less than or equal to 3x cube will stay as it is. How do you evaluate log x the whole power 4? This is also less than x cube, a degree lower than log x, because here we have the term log x is less than x. In that angle we can say that log x the whole power 4 will be less than x cube, and this is for all x greater than 1. So if this is going to be less than x cube, we can have x cube. When I say 2.5 is less than 3, the floor value is 2 and the seal value is 3. Similar way, I am considering the seal value of log x. You can take in that way. What is this actually? 4x cube. 3x cube plus 1x cube is 4x cube. This is actually f of x less than or equal to, this is c and this is g of x. How can I say this is g of x? We have found f of x is big O of x cube. So how do we express f of x in terms of inequality? We will say f of x is less than or equal to c into g of x. From these two expressions, it is evident that g of x is equal to x cube. In that way, we are interpreting this. The other way to write this is f of x is big O of g of x. Now what is g of x? It is x cube. This is what we have found it already here. Now we know the value of c is 4, but here they have asked the value of c and k. We know x is greater than 1 and x is greater than k will state that k is equal to 1. So from this we can say k is equal to 1. And what is the value that we have to find? It is n. So they have mentioned f of x is big O of x power n. Here for this problem, A is stating that f of x is big O of x power 3. What is n from here? N is equal to 3. So just knowing the complexity is more than enough for this problem, but just try to know how to take c and k. It might be useful for you. Now we will solve B. F of x is equal to x power 5 plus x power 2 plus 1 divided by x cube plus 1. Let me take x power 5 plus x power 2 plus 1 and this is x power 3 plus 1. What is the quotient that I can place so that I will get x power 5 here? Let's divide x power 5 by x power 3 alone. So minus 3, this will be x power 2. So I have to take this to the numerator. This will be 5 minus 3, which will give x power 2. I can place here x power 2 so that x power 3 into x power 2 will give x power 5. Then 1 into x power 2 will give x power 2. Now when I subtract, both these terms will get cancelled and I will have remainder as 1. So the quotient is x square and the remainder is 1. We have to express this as x square plus 1 divided by x cube plus 1. This is how we will be writing in form of quotient plus remainder. Now when we have x square here and we have 1 by something here, compared to x square, this is of lower order, something that is less than x square. So while taking the complexity part, we have to drop the lower order term. So I can simply say 1 divided by x cube plus 1 will be lower order term. We need not consider lower order term while calculating complexity. We have to stick to the higher order term. So what is the complexity that you can find here is big O of x power 2. So from x power 2, what is evident? From big O of x power 2, we know n is equal to 2. So we have got previously n is equal to 3 and this is n is equal to 2. This is what we have to find. I will tell you how to do for c and k now. So let's take f of x less than or equal to c into g of x. F of x is reduced to quotient plus remainder. So this will be x square plus 1 by x cube plus 1 less than or equal to c into what is g of x? It is x square. Now let's substitute a number. We have to substitute a number that is greater than k. So if we take k is equal to 1, x should be 2. So for x is equal to 2, 2 square is 4 plus 2 cube is 8. 8 plus 1 will give you 9. This is less than c into x square. Something like 0.1 we will get. This is actually less than c into, here we will substitute now 2 in place of x. This will be c into 4. So when I have 4 point something, that should be less than c into 4. So if c is equal to 1, 4.01 will become greater than 4. So I cannot take c is equal to 1. So let's take c is equal to 2. So that 4.01 will be less than or equal to 4 into 2, which is equal to 8. So let me take c is equal to 2. This will make the equation as 4.01 less than or equal to 2 into 4 is 8. So in this case we can mark c is equal to 2. So we have three values here, n is equal to 2, c is equal to 2 and k is equal to 1. Now let's go for the c part. F of x is equal to x cube plus x square plus 1 divided by x square plus 1. How should we reduce this? We'll have x square plus 1, then we'll have x cube plus x square plus 1. Why am I leaving space here? I will tell you. What is the difference between x cube and x square? It is x. What is x square into x? It is x cube plus what is 1 into x? It is x. Here we have x power 2. So we will place 0 here. Here we should add a term 0 into x to tell that this term is missing. See, when you have power, this will be a constant, then you will have power 1, power 2 and power 3. Power 3 and 2 are filled and the constant is given. This place will have a coefficient of 0 into x to the power 1. Now 1 into x will be x. Just minus this will go, we will have x square. This should be minus, so 0 minus 1 will give minus x plus 1. Now we can have 1 here, x plus 1 will be present here, x square will be x square here plus 1. Again I have to place the 1 here only, I cannot place in x power, so this will be plus 0 into x. Now again subtract, x square and x square will get cancelled, 1 and 1 will get cancelled, this minus x will alone stay. So the quotient will be x plus 1 and the remainder will be minus x in this polynomial division. How will we express this? X plus 1 will be represented here plus minus x divided by the x square plus 1. This term will be represented this way. So the quotient part and the remainder part. While writing the remainder, we have to write along with the divisor, only then it will be correct. What is the higher power here? This is a lower order term. So we can leave this off. Take only x plus 1. So this is big O of x. Big O of x is equal to big O of x power 1, which states that n is equal to 1. So previously we had 3, then we had 2, now we are having 1 as n's value. We have to go for f of x is less than or equal to c into g of x. So what is f of x here? It is x plus 1 plus minus x divided by x square plus 1 less than or equal to c into what is g of x? It is x power 1. So let's take it as x. We will substitute x is equal to 2 as usual because it should be greater than k, where k will be 1. 2 plus 1 will give 3 plus minus 2 divided by 2 power 2 is 4, 4 plus 1 is 5. less than or equal to c into x is actually 2. What is minus 2 divided by 5? So 2 divided by 5 will be 4s are 20. It's 0.4. 3 minus 0.4 less than 2 into c. 3 minus 0.4 is 2.6 is less than 2 into what value if I put in c, this will be correct. If I say c is equal to 1, this equation will be wrong. 2.6 will be greater than 2. So if I put c is equal to 2, this will be 4. So 2.6 less than or equal to 4. So this way I can say the value of c will be 2. Now we will go to the D polynomial. F of x is equal to x square plus 5 log x divided by x square plus 1. Log x is going to be less than x. So 5 into log x will be definitely less than x square. So if I go for division with x square alone, so x square divided by x square plus 1, I have to place only 1 here. This will be x square plus 1 and this will give minus 1 here. F of x will be having 1 as the quotient plus some lower order terms. So I don't want to go with minus 1 and all because we already have 5 log x here. So let's take only this part. Now since it's a constant, what we can say, this is big O of 1. So if I say f of x is equal to big O of 1, how can I express 1 in the form of x bar? I can say x power 0 is equal to 1. So I can say this is big O of x power 0. So from big O of x power 0, what we can say, n is equal to 0. So since 5 log x is less than x square, we have to take this is for x greater than 1 value, which means that k is equal to 1. You remember how we did for A option when we used log. So similarly we will use this also. We will take x square plus 5 log x can be taken as another x square. So this is f of x that is less than or equal to divided by the bottom part x power 2 plus 1 can be reduced to x square again. This will be 2x square divided by x square, where we can cancel this x square and this will be less than or equal to 2. We have something called big O of 1, which means g of x is equal to 1. So this is 2 into 1. From here we can conclude c is equal to 2, k is equal to 1, g of x is also equal to 1. What is the order as per the answer? It is D, then C, then B, then A. D, C, B, A is in option number 2. Option 2 will be the right answer. In examination point of view, what should you do? They are asking you a simple question. What is big O of x power n, and then arrange n alone in increasing order, that is in ascending order. Now you take 3x cube plus log x power 4. You don't mind this log x. Consider this to be lower order term, that is less than x cube. So here you have to consider only 3x cube. From this you can find big O of x cube. So this will give you n's value to be 3. Now for B, consider the first degree in the numerator and the denominator. It is x power 5 and this is x power 3. When you evaluate this, this will be x power 5 minus 3, which will give you x power 2. It is big O of x square, which says that n is equal to 2. Again consider the first degree here. X power 3 by x power 2 will give you x here. So this is big O of x. Then this is taken as x power 1, n is equal to 1. Here we have x square in both the places. So when we have x square in both the places, we can just cancel this and the value will be 1. So big O of 1 can be expressed in other way as big O of x power 0, where n is equal to 0. This is the only way you can do in exam in a short time, because x power 5 plus x power 2 plus 1 is there. In between you have x power 4 and x power 3. Here you have x. Suppose the denominator is going to have x term, but the numerator doesn't have, you will ultimately do a wrong division in the examination due to your tension. That's why it's better you go with this approach. Then the next question that comes to your mind, then why was I keeping on telling all those things? You have to know the process of finding C and K. That's why I included that explanation. Next question. Arrange the following simple graphs based on number of spanning tree they have. So K3 is complete graph with 3 nodes. K4 is 4 nodes. K2, 2 is bipartite graph where one particular part will have 2 nodes and the other particular partition will have 2 nodes. C5 is a cycle graph of 5 nodes. If a graph has m number of edges, the spanning tree will have n minus 1 edges. So how many edges we have to remove from the graph? We have to remove m minus n minus 1 edges. That is m minus n plus 1 edges will be removed in total. Let's take K3. This is K3. We have 3 nodes here. How do you find the spanning tree here? We should either remove this edge to get one spanning tree. We will remove this edge to get another spanning tree. This one, and we will remove this edge to get another spanning tree. Take it to be A, B and C. So there are 3 spanning trees that are possible in K3 graph. Every pair of edges form a spanning tree. So there are combination of 3, 2 they have given. It means 3 factorial divided by 2 factorial into 3 minus 2, 1 factorial. So this will be 3 into 2 factorial by 2 factorial. You will cancel and you will have 3. So they have said from 3 edges, I need only 2 edges here. So for that I am able to find it using combination. This is one way of explanation they have given. Let's see K4. There are actually 4 vertices here or 4 nodes here. Since it's a complete graph, we are having edge from every node to every other node. How many spanning trees are possible here? So let's see step by step. The trees can take 2 shapes, the spanning trees. One shape will be the star. It means I can have 1 here and 3 vertices can be connected this way. This is A, this is B, this is C and this is D. K1, 3 is one side you will have 1 vertex and the other side you will have 3 vertex. And the simple path of length 3 means vertex 1, vertex 2, vertex 3, vertex 4. That is A, B, C, D. It can be in this way or it can be A, C, B, D. It can be this way or any way you can take. Because it is A, it is B, it is C, it is D. You will either have graphs in this way. You can just vertically keep it, horizontally keep it, whatever it is. One vertex connected to 3 other vertices or a simple path of length 3 in this way. So this is the K4 graph. Now they are saying there are 4 different spanning trees possible. If A is here, we have BCD in the bottom line. This is one spanning tree. In case if I take A here and I place B here, this will be ACD. Now you have the second spanning tree. Instead of B, if I use C, it will be ABD. You will have the third spanning tree. Instead of C, if I go for D, then you will have ABC. Because every node is connected to every other node in K4, you will have 4 spanning trees when you have 1 vertex on one side and 3 other vertices on other side. So this way we are able to form 4 spanning trees. What about the simple path of length 3? Actually we have permutation of 4, 4. These 4 vertices can be arranged in 4 ways, which gives a value of 24 orders in which the vertices can be listed in a simple path of length 3. What is P of 4, 4? 4 factorial divided by 4 minus 4, that is 0 factorial. So 4 into 3 into 2 will give 24. There are 24 orders, but since the path can be traversed in either of 2 directions to yield the same tree, there are only 12 trees. When you go by A, B, C, D, you have another order in this way. You have D, C, B, A. So when you want to shuffle this ordering, you need not go with DCBA because you already had ABCD this way. So DCBA and ABCD will give you the same order. Similarly, if you have ACBD, then DBCA will also give you the same order. So whatever you try with A in the first and D in the last, everything can be the same when D goes first and A comes last. Both the things will result in the same tree. Keeping in mind the two direction possibility, we are just taking only half of 24 orders, which will give you 12 spanning trees. So altogether K13 is having 4 spanning tree and simple path of length is having 12 spanning tree, which is going to give you 16 spanning trees of K4 altogether. So there are 16 spanning trees. Next, K2, 2, complete bipartite graph of the two nodes in each partition. So let's take the bipartite graph. So this is going to be one partition and this is going to be the other partition. What is the rule of the partition? It can be connected to any other node in another partition, but it should not be connected in the same partition. So this is P1 and this is P2. P1 can be connected to any number of nodes in P2 and P2 can be connected in any number of nodes in P1. But P1 should not connect any two nodes within itself and P2 should not connect any nodes within itself. K2, 2 is similar to cycle with 4 vertices. A tree is determined simply by deciding which of the 4 edges to remove. If I remove this edge, it's a spanning tree. If I remove this edge, it's a spanning tree. If I remove this edge, it's a spanning tree. If I remove this edge, it's a spanning tree. So how many spanning trees are there? There are 4 spanning trees. So this is with respect to K2, 2. So there are 4 kinds of spanning trees possible. Now let's take it for C5, cycle graph of 5 nodes. This is C5. In cycle you will not have intersecting edges and all. If you cut this one tree is possible. If you cut this one, the second tree is possible. When you cut this one, the third tree is possible. When you have all the 4 edges and cut this one, you will have the 4th one. When you cut this edge, with the remaining 4 edges, you will have the 5th one. So altogether there are 5 spanning trees. When it is C5, it is 5 spanning trees. Just mark A is having 3 spanning trees, B is having 16 spanning trees, C is having 4 spanning trees and D is having 5 spanning trees. What is the arrangement based on the number of spanning trees? We'll start with A followed by C followed by D followed by B. A, C, D, B. Option number 3 will be the right answer. Next question. The height of a binary search tree for the words banana, peach, apple, pear, coconut, mango and papaya using alphabetical order is. What is a binary search tree? Every node in the left subtree is less than the root and every node in the right subtree is a value greater than the root. So take this to be the root. So this is the left side. This is going to be less than the root and this is going to be the right side. This is greater than the root. First we'll have banana. Next is peach. In A to Z order, is P greater than B or not? Yes, it is greater than B. So you have to place it in the right side. So we are placing it here. What about apple? Is it less than B or greater than B? It is less than B because it is A, B. In that case, apple comes in the left side. Let's take the alphabets alone. It is A, it is B. We had P, right? We'll keep it here. Then we will have P again. Then we have coconut. C is here. Then mango is here. So there are 3 P's. One is peach, one is pear, and one is papaya. So apple, banana, peach is there. This particular node is filled with 2 children. Next we have pear. P-E-A-C for peach and this is the first 4 letters. Just compare C and R. C is less than R. So R should be coming in the right side. If you take banana, it has peach already. So peach will have pear in the right side here. Now let's take coconut. It is greater than B. When you come for peach, it is less than P. So in this case, you have to place it in the left side. What about mango? It is greater than B. M, N, O, P. In that order, M is less than P. So we are going to the left side. In left side, you already have coconut. M is greater than coconut. In that way, we are marking mango to be the right side of the coconut. Now the last term, papaya. You are coming to P here. It is PA and peach is PE. A is less than E, so papaya should come this side, and here it is greater than C. P is greater than C, so it is coming to mango. M is less than P, so P is again greater than mango, so it is going to the right side. This is how you have to arrange. So this is A less than B, this is P greater than B, here it is C greater than B, here it is PEAC, PEAR is greater than PEAC, and here we can say M is greater than C, M is greater than B, but M is less than P. And similarly for papaya, papaya is less than peach, that's why it is coming to the left side, and from here papaya is greater than coconut and greater than mango, that is why it is in the right side. Now the question is, what is the height of the tree? The height of a node in a binary tree is the largest number of edges in a path from leaf node to target node. So we have to start from this node and count till this node. So here you can see mango to papaya it is 1, coconut to mango it is 2, coconut to peach it is 3, peach to banana it is 4. So the height of the tree will be option number 3, 4 is the right answer. Next question. Which of the following are true for a complete binary tree? First, let me tell you what is a full binary tree and a complete binary tree. A full binary tree is a tree in which each node has either 0 children or 2 children. If present, both the children should be present, else no children should be present. That is the case of full binary tree. What is a complete binary tree? A binary tree is said to be complete if at all levels except the last level they have maximum number of possible nodes, and there are 2 specific conditions here. Whenever you start constructing a complete binary tree, the leftmost side of the leaf node must always be filled first. In case if you have a diagram ending like this, a binary tree ending like this, it is wrong. It can end this way. It is not mandatory that the last leaf node must have the right sibling. At the same time, you can even stop with this. There is nothing wrong that you have to always have 2 children in the last one. Last leaf node right sibling means this is the leaf node and this is the right sibling. So this right part is not mandatory is what they say. It can even stand with left part. Now I will give you a tree that is both full binary tree and complete binary tree. For full binary tree, they have listed some 6 properties. If T has I internal nodes, nodes means vertices, the number of leaves L is equal to I plus 1. If T has I internal nodes, it has I plus 1 leaves. Is it matching? Yes. If T has I internal nodes, then the total number of nodes N is equal to 2I plus 1. That particular statement is not asked here. If T has a total of N number of nodes, the number of internal nodes is equal to N minus 1 by 2. This is also not asked here. If T has a total number of N nodes, the number of leaves equal to N plus 1 by 2. This is also not in the statement. If T has L leaves, the total number of nodes is 2L minus 1. If it has N leaves, it has 2N minus 1 nodes. This statement is perfectly here. If T has L leaves, the number of internal nodes I is equal to L minus 1. With L leaves, it has not vertices but internal vertices, and the L minus 1 value is also correct. This part is also fine. And in general, a full binary tree will have odd number of vertices. It's full binary tree. This statement is also okay. For complete binary tree, you cannot have odd number of vertices all the time. Say for example, if I have a branch like this and place F here, this is a complete binary tree, but it doesn't have odd number of vertices. 1, 2, 3, 4, 5, 6. There are 6 vertices. And many of the calculations will not work out for complete binary tree for the diagram which I extended with F node. So what I am trying to tell is, which of the following are true for, I will change the question as full binary tree, and I can say option number 4 A, B, C, D are correct. This is why I brought full binary tree inside. In full binary tree, there is no possibility that you will have only left child. You cannot leave the diagram with left child alone. You have to either leave both the children or put both the children. Only then it is full binary tree. So if I place a node here, it will not be a full binary tree. When I place another node here, this becomes a full binary tree again. When you place F and G here, now count the number of vertices, it will be odd. When you take a node and two children, the count of vertices is 3. When you take only a node, the count is 1. When you have a node and only one child here, the count is 2. This is not possible in full binary tree. That's why we say full binary tree always has odd number of vertices. All the 4 statements here, it must be a printing mistake because remaining 3 statements are there, and A, B, D you don't have any option. A is right, B is right and D is right. Except for the printing mistake, if they would have inserted internal here, A, B, C, D would have been the right answer. So taking this to be a printing mistake, we will mark option 4 as the right answer, but not for complete binary tree but for full binary tree. Next question, which of the following sequence are the solution of recurrence relation? A recursive definition of a sequence specifies one or more initial terms and a rule for determining subsequent terms from those that precede them. Let's take Fibonacci series. It is 0, 1, 1, then 2, then 3, then 5. We will usually say F0 is equal to 0 and F1 is equal to 1. F2 will be F0 plus F1. F3 will be F1 plus F2. Recursive definition is when you have one or more initial terms, these are the initial terms, and a rule for determining the subsequent terms from the previous terms. So these are the previous terms and this is the rule. So just like Fibonacci series, for many other problems you have recursive relation. So everything will have a sequence. Sequence means a set of numbers with some rule. So here this is a sequence. Let's take A0 is equal to 3 and A1 is equal to 5. An is given as An minus 1 minus An minus 2. Substitute n is equal to 2. So in that case we will have A1 minus A0 which is equal to 5 minus 3 which is equal to 2. So from the previous term we are finding the subsequent term. A rule to determining subsequent terms from those that precede them is called recurrence relation. This recurrence relation will give the value of the subsequent terms from the preceding terms. The terms that precede the first term where the recurrence relation takes effect are called initial conditions. So if we start from A2, then A0, A1 will be called as initial conditions. The recurrence relation and initial conditions uniquely determine a sequence. So this is the definition that matches the question. A recurrence relation for the sequence An is an equation that expresses An in terms of one or more of the previous terms of the sequence, namely A0, A1, An minus 1. For all integers n with n greater than or equal to n0, where n0 is a non-negative integer. It means it should be positive. What is a sequence then? A sequence is called a solution of the recurrence relation if its terms satisfy the recurrence relation. So they have given the recurrence relation. They are asking which sequence will satisfy this recurrence relation. Here we have to compute the sequence of all the 5 options A, B, C, D, E and then find whichever matches the recurrence relation. We will do it now. Now let's take the recurrence relation. An is equal to 8 into An minus 1 minus 16 into An minus 2. Now substitute n is equal to 2 here. This will become A2. N minus 1 will become 2 minus 1. N minus 2 will become 2 minus 2. From here we get A2 is equal to 8 into A1 minus 16 into A0. So what we will do is, first we will take the sequence. We will find A0, A1 and A2. We will substitute A0 and A1 in this recurrence relation and check whether we get the right A2 value. Let's first take the A sequence. An is equal to 1. What is A0? It is 1. What is A1? It is going to be 1. What is a2? It is going to be 1. So they have kept a constant here in the right hand side, that is not going to change. Now let's check recurrence relation. a2 is equal to, what is 8 into a1? Pick a1 from here. 8 into a1 is 8 into 1 minus 16 into a0 is 16 into 1. What is 8 minus 16? It is minus 8. Do we get minus 8 here? No. Then this is not a solution. Let's go for B. We have an is equal to 2 power n. What is a0? It is 2 power 0, which is equal to 1. Then we have a1, which is equal to 2 power 1, which is equal to 2. Then what is a2? 2 power 2, which is equal to 4. Now let's substitute in recurrence relation. a2 is equal to 8 into, what is a1? It is 2 minus 16 into, what is a0? It is 1. 8 into 2 is 16 minus 16 into 1 is 16, which is equal to 0. Here we are getting 4 and here we are getting 0. So this is also not a solution. Now let's go to C. an is equal to 4 power n. Let's take a0, which is equal to 4 power 0. This is equal to 1. So a0 is equal to 1. Then we'll have a1 is equal to 4 power 1, which is equal to 4. a1 is equal to 4. Then a2 will be 4 power 2, which is equal to 16. Now we'll go to a2 in recurrence relation. 8 into a1 minus 16 into a0. This will be 8 into a1 value is 4. 8 into 4 minus 16 into a0 value is 1. 8 into 4 is 32 minus 16 into 1 is 16. 32 minus 16 is 16 again. What is a2 here? a2 is 16. Here also a2 is 16. Is it matching? It means this sequence is a solution of the recurrence relation given here. Next we will compute for D. an is equal to n into 4 power n. a0 is equal to, what is n? 0 into 4 power 0 is 0. So a0 is 0. What is a1? 1 into 4 power 1, this is equal to 4. So a1 is equal to 4. What is a2? 2 into 4 square. So 2 into 16 is 32. We have a2 is equal to 32. Now we will check a2 here. It is 8a1 minus 16a0, which is equal to 8 into a1 value is 4 minus 16 into a0 value is 0. 8 into 4 is 32 minus 16 into 0 is 0, which is 32. a2 is equal to 32. Did we get 32 here? Yes, we got. This is also a solution. Next we will check E. We have an is equal to minus 4 power n. a0 is equal to minus 4 power 0. This is 1. So a0 is 1. a1 is equal to minus 4 power 1, which is equal to minus 4. This is minus 4. What is a2? It is minus 4 power 2, which is equal to 16. Minus 4 into minus 4 is equal to plus 16. So a2 is equal to 16. Now let's calculate a2 here. It is 8 into a1 value is minus 4 minus 16 into a0's value is 1 minus 4 into 8 is minus 32 and this is minus 16 into 1, which is equal to minus 16. This will give a value of minus 48. a2 is minus 48 here, but it is 16 here. This is not a solution. So which of the following sequences are the solution? C and D are alone the solution for recurrence relation. Option number 3, C, D only will be the right answer. So make sure you find a0 and a1, because when the recurrence relation is having n minus 2 and n minus 1, you have to make this as 0 and 1. So the only way of doing this is making n is equal to 2. So for n is equal to 2, n minus 2 will become 0 and n minus 1 will become 1. You can also say preceding terms instead of initial conditions. Next question. If f of n is equal to 5 into f of n by 2 plus 3 and f of 1 is equal to 7, is a recurrence relation where k is positive integer, then f of 2 power k is equal to what? We have a formula to do that, but before getting into the formula, I'll tell you the story first and then go for the calculation. Previously we saw a match with divide and conquer algorithm and recurrence relation. So from that part only they have asked this. If f of n represents the number of operations required to solve the problem of size n, it follows f satisfies the recurrence relation f of n is equal to a into f of n by b plus g of n. Let f be an increasing function that satisfies the recurrence relation whenever n is divisible by b, where a is greater than or equal to 1, b is an integer greater than 1, c is a positive real number. Then we have f of n is equal to big O of, this can be written as big O of n power log to the base b a if a is greater than 1, this is the case. Furthermore, n is equal to b power k and a not equal to 1 where k is a positive integer. In this case, we have f of n is equal to c1 into n power log a to the base b plus c2. Here we have c1 is equal to f of 1 plus c divided by a minus 1 and c2 is equal to minus c divided by a minus 1. Now suppose that a is greater than 1. First assume n is equal to b power k where k is a positive integer. From the formula for the sum of terms of geometric progression, they have given a formula. Finally, they have equated it to this part. But the formula is given in this form. A power k into f of 1 plus c into a power k minus 1 divided by a minus 1. So here what we are doing is we are applying this c inside and bringing this to this part. Now just take this as a power k f of 1 plus c into a power k, bring the denominator to this part, then you have minus here, then you have a c here, then a minus 1. You can take this as plus and this to be minus. So I am taking a power k here, this will be f of 1 plus c divided by a minus 1. Then this plus or minus together can be written like this. This part is actually mentioned here. You have to apply all the values of the question in this formula. Now let's get into the solution part. We have f of n is equal to a into f of n by b plus c. So this is f of n is equal to 5 into f of n by 2 plus 3. From here what we can understand? A is equal to 5, n by b means n by 2, b is equal to 2 and c is equal to 3. And they have mentioned here about n is equal to b power k. Here n is equal to what is b? It is 2 power k. What they are asking us to find? F of 2 power k. So now we have to find f of 2 power k. What is a? It is 5. We will retain the k as it is. Now, what is f of 1? F of 1 is actually given as 7 in the question here. So, we will take 7 plus, what is c? It is 3 divided by, what is a minus 1? It is 5 minus 1. Minus c, we have 3 and a minus 1 we have 5 minus 1. This is equal to 5 power k, 7 plus 3 by 4 minus 3 by 4, which is equal to 5 power k. We have to find LCM. 7 into 4 is 28 plus 3 divided by 4 minus 3 by 4, which is equal to 5 power k. We have 28 plus 3 is equal to 31 divided by 4 minus 3 by 4. This is the answer for f of 2 power k. Which option is equating to this? Option number 1 will be the right answer. This is not a so difficult formula. I will write it in a normal way instead of this printing way. This is a power k. You have open bracket here, f of 1 plus c divided by a minus 1. Then have a subtraction here. This term is again repeated here. With this, we are completing Unit 7 solutions.